Hi everyone, this is Zach. How many of you heard that the math works on the globe Earth model but it doesn't work on the flat Earth model? Have you ever tried to see if this is true? Have you ever tried to debunk it? Have you ever tried to see how Eratosthenes and others ended up believing in the globe model a long time ago? Their math was really impressive. We still use it today. It worked pretty good. But does that mean that we really live on the globe? Does that mean that if the math works on anything, then this anything must be what the math says? The math doesn't lie. Yes, that's true. But what if we unintentionally miss something while doing the math, and we impress the entire world, generation after generation, and 1,000 years later, someone else discovered the missing piece, then he did the math again, and he found out that all the calculations were incorrect. If you were him, what would you do? Sit back and sleep, or tell everybody? Would people believe you? This video is very important and it needs a lot of concentration, so leave whatever you are doing and focus on this video. But if you watch the entire video and you still feel like you didn't get the point, then watch it again and you will get it, trust me. One more thing. We will work with numbers here, but don't panic. Even if you were the worst student ever, you will still understand it because the math here is more than easy and all you have to do is focus. Alright, we're gonna talk about how they thought that the Earth is a globe 2,000 years ago. A man called Eratosthenes supposedly measured the globe Earth circumference using his brain only. And our scientists today agree with his method and they say that his calculations are very accurate. And I agree with that, but now I'm gonna show you how his math can be accurate when reality is completely different. I got another team from Indonesia right now, and their leader is named Boss Darling from the Flat Earth 101 channel. Please take a look at it and subscribe. Well, I planned an experiment and they did it and it works as I planned. This experiment is gonna prove to you how we can convert a flat table to a round table. Yes, you heard me. We're gonna convert a flat table to a round table using mathematics and shadows. In other words, we're going to redo Eratosthenes' experiments in a small scale, considering a flat table as the flat Earth. Alright? But before we get to that, I'm gonna have to explain to you a few things so you can fully understand the experiments because it's a bit complicated. Now, the first thing we're gonna start with is the angles of elevation of the sun. I'm sure that most of you know how they work, but this time I want to go deeper. So even if you already know what I'm talking about, be patient and keep on watching till the end. Don't blink. Okay, if you place a stick on the ground to measure the shadow, you get 3 angles. This is called the base of the triangle, which has to be 90 degrees. This is the angle of elevation, and this is the angle that Eratosthenes used in his math. I couldn't find a good name for it, so I'm just gonna call it the angle of deception. Now here are the most common questions that most people ask. Why did Eratosthenes assume that the Earth is a globe in the first place? Why did he use this specific angle to measure the circumference of the Earth? Okay, let's answer these 2 questions at the same time. We know Eratosthenes' experiments was just made up by some people, but let's assume it's real. Well, as far as history is concerned, Eratosthenes was not the first guy who thought that the Earth could be a globe. But our topic today is not who was the first person who claimed the Earth is a globe. Our topic is why they claimed it's a globe. The answer is simple. They used the angles of the sun. These angles can be either vertical angles or horizontal angles, and both of them do not work on the flat Earth. They can only work on a globe Earth. But today, we're just going to talk about the vertical angles or the angles of elevation. And here is why they don't work. If you put a lamp on a flat disk and you try to triangulate it using the shadows like I did in this video a year and a half ago, you will be able to triangulate it perfectly and the elevation angles will work. In other words, if you put this in a 3D program and you draw imaginary lines or cones like these ones in the air to represent the light rays, they will all intersect in the center of the bulb. So no matter how many objects you use, you will always be able to locate the bulb by using 2 things. 1, The elevation angles, they can be calculated by the shadows and the length of the object. 2. The distances between objects. Try to always use a 3D software to make your math easier. Is that clear now? Okay, let's clear this up a little bit more because it's the basis of this topic. So let's repeat the experiments we have done a long time ago. But this time we're gonna use 9 objects on a flat table to triangulate the bulb and not just 3. And of course, I'm gonna show it to you in AutoCAD so you can understand it, and then I will show it to you in real life. And be patient, this is just part 1 of the experiment. So here is the table. We got an A3 paper on it and 9 nails, as you can see. Imagine you are on that paper, and that paper is the earth, and this bulb is the sun. It's 50 centimeters above the table. It's exactly 90 degrees above the nail in the middle. All the nails are 5 centimeters except the one in the middle. And the distance between each nail is written on the paper, as you can see here. Our units of measure is centimeters, okay? Some people think that if you use more than 3 objects, you will not be able to triangulate the bulb. They're wrong. If you model it and do it in real life, you will get the same results. All the elevation angles, or better said light rays, come from the center of the bulb, and all the depression angles go to the tip of the shadows. So light rays of the experiment should intersect in the bulb. Here are the measurements that we got in AutoCAD. But of course, this is just a 3D program. Now we're gonna do the same exact thing in real life, and we will get the same length of the shadows. And I am so sorry that I have no way to prove to you that we are not faking this experiment. Well, I guess there is only one way to find out. You're gonna have to do it yourself. Don't trust me, trust yourself. Here are the guys who did the experiment: AG and Iban and Ayat and Damar. So here is the experiment. The nails are 5 centimeters long. The one in the middle was put there just to demonstrate that the bulb is 90 degrees above it. And as you can see, it has no shadow at all. The farthest nail is 15 centimeters away from the center, and the closest is 5 centimeters away from the center. And the last one is 10 centimeters away. We used 9 nails and 3 distances because the lens was not big enough. They put the 5 centimeter nails and the bulb in the appropriate distances, and here are the measurements of each shadow. Please compare them to the results of the 3D model that you got on the screen. If you do this correctly, you will get a very precise results. I did this before, and people who have been following me already know it. So if you are new and you want to watch this with great detail, just click on this link right here and watch my other video. You will find the link in the description. The 3D model here matched reality so accurately. All the shadows that I got in the 3D model matched the shadows that we got on this table. And as I said before, that was just part 1. Wait for part 2. Now, if we were Eratosthenes' friends and wanted to do the same thing with the sun in real life, our experiments would fail. We would not be able to triangulate the sun. The cones or the lines that we would draw to triangulate the sun would not intersect in one point like in the 3D model that I just showed you. And this is gonna make us think that the earth is not flat, because the triangulations worked on the experiments that we did on the flat table, but did not work on the sun in real life. So something must be wrong. You would think, what is it? This must mean that the earth is not flat. So if we really were those scientists, you would have to think about something else, like the earth being a globe, for example. Yeah. So this is how they came up with the globe theory. The angles of elevation led them to think about the globe model. They were just assumptions based on mathematics. Forgive me, but I'm gonna say this one more time. If you use more than 3 positions to triangulate the sun, assuming that the earth is flat, your triangulation will never work. No matter how hard you try, you will always fail. The sun rays will never intersect in one point. I have been doing this for a long time and I had to come to this conclusion. Some of you might think that if the distances between the objects are not accurate, then the triangulation will not work. And I agree with that, but even if the distances were 100% accurate, the triangulations would never work. And I'm gonna prove what I'm saying with another experiment. As we said in the previous videos about refraction, the sun is never in its real position. Even modern science agrees with us. What you are triangulating is a reflection of the sun. And this is why your triangulation will never work. Imagine yourself in the bottom of a swimming pool trying to triangulate a bulb that is above the water. You will never be able to triangulate it unless you know how refraction works on water. The experiments will explain this better. Just stay with us. So Eratosthenes and his friends decided that the Earth is not flat because there was no way to make the angles of elevation work and make sense. For example, whenever they triangulate the sun from two positions, the distance to the sun appears to be around 3,000 miles. And at the same time, they triangulate it from two other positions and they get a distance of 4,000 miles. Solving this at that time was impossible, and it was still impossible to us until a few months ago. Anyways, these mathematicians had to find a way to make these angles work, so they assumed that the Earth is a globe and the sun rays come to Earth in parallel lines, because this was the only way to make the angles work. So their only problem was how to know the circumference of the Earth so that angles can work perfectly. Eratosthenes supposedly had this brilliant idea. There was a well in Syene in Egypt, and the sun used to pass directly above it once a year, which means that the sun at that time was 90 degrees above that well. The next year, at the same time and date, he went to Alexandria and he placed a stick on the ground and he noticed that the stick had a shadow. So he measured this angle of deception and it was 7.2 degrees. So he thought that the Earth must be a sphere and that he could calculate it. He just needed to know the distance between Syene and Alexandria. So he sent a guy to measure the distance, which was about 5,000 miles or 800 kilometers. So this angle right here, 7.2, has to be equal to the central angle of any sphere, and that made everything else easy for him. A sphere is 360 degrees, so all he had to do is divide 360 by the angle of deception, which was 7.2 degrees, to get 50. So if we draw a circle like this and draw a line like this and repeat it 50 times, it will give us this angle, 7.2 degrees between each two lines. So in order to get the circumference of the Earth, he had to multiply 50 by the distance, which was 500 miles, and he got 25,000 miles or 40,000 kilometers. So that has been the circumference of the Earth since that time, which is really precise for someone who had no equipment at all. Very smart move, NASA. All you had to do was correct the calculations a bit more, and that's it. Now the math works beautifully on this new circumference of the globe Earth, 24,900 miles. I wonder if you were a scientist and you wanted to prove that the Earth is a globe, would you just do one experiment and that's it? Did this guy Eratosthenes repeat this experiment many times in different places before assuming it's a globe? Okay, doesn't matter now, let's just believe it. Okay, let me show you how the angles work on the globe model. It doesn't matter how big the globe is. The angles will work the same, but we will use this exact radius of the Earth, 3,959 miles. I'm gonna divide the Earth into 24 parts because it takes the Earth 24 hours to rotate. So, here is the distance between each point. And that means that if you are here, your elevation angle will be 90 degrees because the sun is right above your head. So imagine you got friends all over the globe. Your friend right here would not have the sun directly overhead because he is 1 hour away from you. So his elevation angle is going to be 75 degrees because the Earth rotates 15 degrees every hour. So every hour you will have 15 degrees less. Here you're gonna have 75 degrees, and here you're gonna have 60 degrees, and here 45 degrees, and so on. If this is confusing, then here is an easy way to know if this is accurate. Please go to suncock.org and go to the equator and make sure your latitude is around 0 degrees. You can change the date to the 21st March because the sun is above the equator at that time. And also change the time to 1 p.m. UTC plus 1. And then try to click around to find the 90-degree angle of the sun. Once you find it, change the time from 1 p.m. to 2 p.m. and you should get 75 degrees in the altitude of the sun. Now if you change it to 3 p.m. you should get 60 degrees. So this is how the angles of elevation work on the globe. If we can make these angles work on the flat earth model, we will be able to know the degrees and the distances between each position on earth. And that will help us draw an accurate flat earth map, and our map will be undebunkable. So, to everyone who work on the flat earth map, please forget about the flight's duration and time zones. They will never ever help you draw an accurate map. Focus only on the angles of elevation and the horizontal angles, or what we call azimuth. And we're gonna talk about this in detail in the future. Now let's get back to what we have been doing. Do you realize now the weakness of the flat earth? If yes, then you will love what's coming next. Eratosthenes had no idea what the atmosphere is. So he just assumed that the sunlight comes in straight parallel lines to make his math work, and it did work. Now we know that the atmosphere bends the light. So if the sunlight really bends, then how come Eratosthenes' math is correct? It doesn't make any sense. His math was based on straight lines. So I believe that in order to save the globe model, our scientists told us that the atmosphere bends the light, but it's almost unnoticeable. So if the apparent sun is right above the horizon line, that means that the real sun is right below it, and the angle between them is around 0.84 degrees approximately. So are we supposed to believe this without any experiments to back up their claim? To me, this is just an assumption. The air is full of water and gases, and we know that water affects the light a lot. The air sometimes magnifies objects. It makes them look bigger and closer. Sometimes it works like water, sometimes it doesn't. We really don't know what it is or how it works. So scientists, please stop making up assumptions based on numbers. Okay, right now we're gonna redo Eratosthenes' experiments, but this time we will use refraction. The difference between part 1 and part 2 is refraction, so we added a concave lens to represent the atmosphere. The rest is still the same. And no, we are not saying that the atmosphere is concave. We don't know what it is. Each lens will give you an interesting result, so we chose a concave lens. So please focus on this because it's gonna blow your mind. I'm gonna do my best to make it as easy as possible to understand. So the concave lens is 30 centimeters above the table and the bulb is still at the same height, 50 centimeters. The nail that is in the center of the paper is 90 degrees below the lens and the bulb. That is why it has no shadow at all. We put it there just to make sure it is 90 degrees below the bulb. The distance between each object is still the same as before, but as you can see now, the shadows are longer than before thanks to the concave lens. And this is what a concave lens does to the light. It makes light rays diverge, and this is why the shadows become longer. Okay, let's watch the experiment. I'm gonna put all the details on the screen because it's hard to see the numbers, okay? So we're gonna start with 10 centimeters distance. Before adding the lens, the shadow was 1 centimeters and now it's 1.7 centimeters. It's longer now than before. This nail right here is also 10 centimeters away from the center. And its shadow is the same as the previous one, 1.7 centimeters. This one is 5 centimeters away from the center, and before adding the lens the shadow was 0.5 centimeters and now it's 0.83 centimeters. This one is the farthest, and it's 15 centimeters away from the center. Its shadow before adding the lens was 1.5 centimeters, and now it's 2.69 centimeters. We're using 2 decimals to show you how precise this can be on the globe table that you're gonna see later. This shadow is the same as the previous one, 2.69 centimeters. This nail is also 10 centimeters away from the center, and its shadow is also 1.7 centimeters. And this is another one that is also 10 centimeters away from the center, and its shadow is also 1.7 centimeters. The last one is 5 centimeters away from the center, and its shadow is 0.83 centimeters. As you can see, even if we changed the directions of the nails, they had the same shadow. So the distances we are going to work with are 5, 10, and 15 centimeters. And the shadows we're going to work with are 0.83, 1.7, and 2.69 centimeters. Okay? So right now we are going to run a few tests. The first one is going to be triangulating the bulb using these long shadows. So to triangulate it, I'm going to have to model everything and make our math simple and easy to understand. So this is what I did. I draw the same thing you see on the table, and I draw a line from the tip of each shadow to the tip of each nail, and I just made the line longer to see where all these lines are going to intersect. Because if the light rays are coming from the bulb, then all the lines will intersect in the bulb like in the first experiments, right? But as you can see here, the light rays are not intersecting in the bulb, but they all go through the lens. So that means that the lens is what is causing the shadows to become longer. Now imagine yourself so small on this paper, and you are trying to triangulate the bulb, but you have no idea if there is any lens in the sky, because you just can't see it like you can't see the atmosphere. So your triangulations will always fail, because they will always give you a different distance to the bulb, because the bulb is not what you think it is. You are just triangulating a reflection of it. If you were so small on that paper, then the lights you will see is just another image of the lights that is projecting somewhere on the lens. But from the table you cannot see it. So if you don't consider the lens, your math will not be correct, even if you make it work. Please imagine Eratosthenes is on that table right now looking at the bulb through that lens. Can he see where the real bulb is? Of course not. So he's gonna do some triangulations to know how far the bulb is. But he is so smart, he automatically realized that triangulating the bulb from a flat lens would never work, because every time he does that, he gets different distances to the bulb. So he thought that the table cannot be flat, because if it was flat, then the elevation angles or light rays will intersect in the center of the bulb, exactly like in the first experiment. He has to think that the table is round, because the math will only work on a round table, because he had no idea what the atmosphere can do to the light. So this is what Eratosthenes did in details. Imagine this nail on the left side is Alexandria, and the nail in the middle is Syene. Sine in his experiments was 90 degrees below the sun, so that nail in our experiments is also 90 degrees below the bulb. Now the distance between Sine and Alexandria was 800 kilometers or 500 miles. But in our experiments, we can just assume it's 15 centimeters. We could have used 80 centimeters to scale it down, but we didn't have a bigger lens to cover that much distance. But it doesn't matter because the math of Eratosthenes works with all distances on the globe, and I'm gonna prove that to you too. Well, the shadow of this nail that represents Alexandria is 2.69 centimeters. So, to get the angle of deception that Eratosthenes used in his experiments, all we have to do is draw the nail that is 5 centimeters and draw the shadow that is 2.69 centimeters. And then we measure this angle and it is 28.26 degrees. So Eratosthenes divided 360 by his angle of deception, which was 7.2 degrees. But in our case, it's 28.26 degrees. So we get 12.73 centimeters and many decimals. Then Eratosthenes multiplied the results by the distance. If we want to do the same thing, then we should multiply 12.73 by 15 centimeters. So we get 191.08 centimeters in circumference. And that means that 191.08 centimeters is the circumference of the globe table. Now we can assume that the table is a globe because the angles work on it, right? So the table is now a globe with a circumference of 191.08 centimeters, which makes its radius to be 30.4113 centimeters. Okay, that's fantastic, but hey, get back here, we didn't finish yet. We are way better than Eratosthenes. We're gonna prove that the table is a globe by doing too many measurements and not just one. First, I'm going to measure the elevation angle of each nail. Here we go. This is the closest nail to the central nail, which is 5 centimeters away from it. Its angle of deception is 9.42 degrees and its angle of elevation is 80.58 degrees. Same thing for the other nail in the opposite side. They got the same shadows. Now, if we want to do Eratosthenes' formula, then we will do this. 360 degrees divided by 9.42 degrees, we will get 38.21 and many decimals. 38.21 times the distance, which is 5 centimeters, we will also get 191.08 centimeters. The result is like the first circumference we got from a distance of 15 centimeters, if you remember. Now we will do the same thing with the last distance, which is 10 centimeters, and we should get the same circumference. Let's take a look at its angle of deception, 18.84 degrees. So again, 360 degrees divided by the angle of elevation, that is 18.84 degrees, we get 19.1 and many decimals. 19.1 times 10, we get 191.08 again. And the angle of elevation of this one is 71.16 degrees. Let's test these angles on a ball like we did on the globe model. Let's see if these angles really work. So I'm gonna draw our globe table with a radius of 30.4113 centimeters. Circumference of 191.08 centimeters. Now I'm gonna draw the distance of 5, 10, and 15 centimeters on the globe table, because these are all the distances we used in the experiments with 9 objects. I was gonna use longer distances, but we only had a small concave lens that can't cover a bigger distance. So these are the distances. Now imagine the bulb rays are parallel just like the sun rays. The nails should be perpendicular on this globe, but we don't have to draw them because they are not necessary. So I'm gonna draw parallel light rays above these positions of these invisible nails that are on the globe now, not a flat surface. Now I'm gonna go ahead and draw tangent lines to be able to measure the angles. Now, as everything is drawn, we can start measuring the angles and comparing them with the angles we got on the flat table. Let's start with the angles of elevation. First, we will calculate the angles of the 5 centimeter distance. The angle of elevation is 80.58 degrees. The angle of 10 centimeter distance is 71.16 degrees. The angle of 15 centimeters distance is 61.74 degrees. If we compare them to the angles we got on the flat table, we get the same exact angles. Does that mean that the table is a globe? No. The problem here is that we are not accounting for refraction. We are just doing the blind math that Eratosthenes did 2,000 years ago. So refraction made us think that the flat table is actually a globe because the math could only work on the globe. You want to measure the angle of deception of Eratosthenes? Let's go back to our drawing. Now watch. Here is the first angle that has to be 9.42 degrees. The second angle should be double, so it has to be 18.84 degrees, and the third one has to be triple, 28.26 degrees. You will get these angles everywhere on this globe. Does that mean that the table is a globe? The math here works perfectly. Eratosthenes' math was simple and genius, but it's all wrong because he never accounted for refraction, and now our scientists are making refraction meaningless so that math can still work. But no, sir, refraction is not meaningless at all, and we can prove that day after day. And again, I'm not saying that the atmosphere is concave like this lens. I'm just giving you an example of one type of refraction that worked on the globe and didn't work on the flat plane, even if reality is a flat plane. And this is why they don't work on a flat table or a flat earth. If you are here and got friends everywhere on the table and all you have is the distance between all of you and the angles of elevation, then your lines of triangulation will meet somewhere on this line, way below the bulb. And that makes your triangulation incorrect. So you will end up saying that the table is a globe with a circumference of 191.08 centimeters, just like Eratosthenes. Well, smart people should already realize that the bulb we created by calculating angles from shadows has the same radius of the concave lens. Now, if the lens was bigger and the bulb is circling around it, and Eratosthenes is a small guy on the table, he will think that the table is a globe because the angles work on the globe. Here is something to think about. What if the sun circles above the concave lens? Or what if the concave lens is the one that circles below a fixed sun? What if this concave lens has the same radius of the Earth, 3959 miles? If that's so, then I would have done the same math as Eratosthenes and told you that the Earth is 25,000 miles in circumference as well. Do we deserve a like and share?
We hope you enjoyed this video presentation by Dr. Zach. If you found this video informative, please like and share and subscribe to Dr. Zach. You can email Dr. Zach at zicoworld123@gmail.com. And thank you for watching.